Introduction to Trigonometric Ratios. Learning targets. Find the sine, cosine, and tangent of an acute angle. Use trigonometric ratios to solve real-life problems, such as estimating the height of a tree or flagpole. You have two essential questions. If trigonometry deals with finding the missing side lengths of right triangles, why can't I just use the Pythagorean theorem? Can trigonometry help me solve real-world problems? Definitions. Trigonometry is the study of the relationship between sides and angles of triangles. A trigonometric ratio is a ratio of two sides of a right triangle. The three basic trig ratios are sine, cosine, and tangent, which are abbreviated as sine, cosine, and tangent respectively, and we'll show you their definitions momentarily. So here we have a right triangle ABC where C is the right angle. The sine, cosine, and tangent of acute angle A are described or defined as follows. The sine of A is the measurement representing lowercase a over the measurement representing lowercase c. The cosine of A is defined as the side adjacent to angle A over the hypotenuse. And the tangent of A is the side opposite A over the side adjacent to angle A. So we're going to use these ratios. Here we have a right triangle. Well, actually, we don't know if it's a right triangle, but what we should do is probably test it out. Is 8 squared plus 15 squared equal to 17 squared? 64 plus 225 equals 289. So yes, triangle ABC is a right triangle. So now we can figure out the sine of angle A is the opposite over the hypotenuse. So that's 8 over 17. Typically we leave it as a fraction, but sometimes you'll be asked to represent it as a decimal. Usually we round to the nearest hundredth. It would have been 0.47. The cosine of A is the adjacent over the hypotenuse. So that's 15 over 17, around 0.88. And the tangent of A is the opposite over the adjacent, approximately 0.53. Here I have a right triangle. We're asked to find the sine of angle G. So the first thing we need to do, because sine deals with opposite over hypotenuse, is we need to find the hypotenuse of this triangle. And we'll do that using Pythagorean theorem, and it's also a 3, 4, 5 right triangle. So now I know the opposite is 3 to angle G, the hypotenuse is 5, so the sine of G is opposite over hypotenuse, or 3/5. The cosine of angle G is the adjacent over the hypotenuse, or 4/5. And the tangent of angle G is the opposite over the adjacent, and that's 3/4. So we could use a calculator to find the cosine of 72 degrees. And you'll notice the trig functions, they're labeled sin, cos, and tan. So we're going to click on cosine, and then we'll type in 72, and we should get about 0.31. If not, check that your mode is in degree mode and not something called radian mode. And so you can experiment with your calculator there to make sure you get 0.31 approximately. The sine of 30 degrees, find your sine button, type in 30, and you will get 0.5 exactly. And the tangent of 70 degrees is 2.75. So we can use a calculator to also help us solve more challenging problems. So here we have an example of a right triangle. The 72-degree angle is given, and we're asked to find E. And we're given a hint, if we use the tangent ratio, we can find E. So think about tangent, right? It's opposite over adjacent. And now you can solve for E by rewriting this as a multiplication problem. And you can type that into a calculator, and you get approximately 40.01 units. So here we have another right triangle, and we're asked to find x, which is the hypotenuse of this right triangle. Remember, one of our essential questions was, why can't we just use the Pythagorean theorem? Well, we could if we knew the two leg lengths, but see, we only have the one leg length here. We only know the height of this triangle is 8. We have the angle of 32 degrees. We're missing the hypotenuse. And so sine is the best trig function to use because that's opposite over hypotenuse. And so we know that x times the sine of 32 degrees equals 8. Some people solve this by cross-multiplying like this, and then they'll divide both sides by the sine of 32 degrees to get approximately 15.10 for x. So here's our real-life example. The escalator at the Wilshire, Vermont Metro Rail Station in Los Angeles rises 76 feet at a 30-degree angle. Find the distance d a person travels on the escalator stairs. So I always tell my students, when something is described to you in words, it's a really good idea to draw a diagram. And so here's my diagram. I know that this is a right triangle, and I know that the height is 76 feet because that was given in the problem. Notice the base angle I drew in at 30 degrees, and I'm trying to find d, which is the hypotenuse of this right triangle. So I think if I use sine, which is opposite over hypotenuse, I feel like that will help me. The sine of 30 degrees is opposite over hypotenuse. And now I want to substitute in opposite equals 76 feet. And now I'm going to just use the symmetric property to rewrite this equation this way. That might be the reflexive property. And now to solve for d, I can just use an equivalent equation, 76 divided by the sine of 30, and use my calculator, and I get 152 feet is the distance a person travels. So that escalator is saving them quite a few steps, right? I want to summarize with you the introduction here to trig ratios. They're the ratios of the side lengths of a right triangle. Sine, cosine, and tangent are what we talked about today. Later on we'll learn about inverse trig ratios, but this was today's topic. Calculators can definitely help. Make sure it's in degree mode if the degrees are given in a problem. And finally, there's a little memory device that I thought might be good to show you. And that's the SOHCAHTOA. You'll hear maybe a teacher say this, and that is that SOHCAHTOA. And I usually have kids practice saying SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent.